Hi, this is Mike Hendrickson from Velocity in New York City. I'm here with Mike Strickland from Intel. Mike, how you doing?
I'm good, thanks.
How has this event been for you so far?
Fairly good. This is a new area for Programmable Solutions Group of Intel, FPGAs, the data analytics area, but we have a lot to talk about at the show.
FPGAs, can you unpack that a little bit? I mean, it's an acronym.
It is. So FPGA stands for Field Programmable Gate Array. They've been around for decades, but hidden away in communication devices. And our challenge now is to have them play a role in data analytics and still keep them hidden.
So keep them available for like DevOps. Why would a DevOps person or someone in an organization that's concerned about performance want to use an FPGA to help their IT transform or become better? What is the play there?
Sure. So as you know, I mean, the struggle in big data, it just increases every year. The massive amount of data, the challenge to do the data analytics. And FPGAs can play quite a role to accelerate many of the data analytics workloads, all the way from traditional relational database to NoSQL and to flat files. So we have opportunities to have the FPGA do that type of acceleration. And again, hiding the FPGA with Intel frameworks that the FPGA can integrate to, such as Spark frameworks, or partners just coming in as a storage plugin to a database like MariaDB. So we have a number of opportunities now to help these data centers that are struggling with increasing demands to accelerate their workloads using the FPGA.
And so a lot of the data centers that are struggling, they may have a data team that's trying to help that, but then if you look at it organizationally, does that roll up to a DevOps type person that has to deploy all these systems and deploy the technologies? Are they the ones that are going to be involved with the FPGAs as well?
Yes, absolutely. So they're probably being charged with trying to manage the IT budget to a reasonable amount while meeting everyone's service level agreement requirements and new applications. And FPGAs can play quite a role to make that job easier to implement. So as an example, we have a partner, Swarm 64, who can take real-time data analytics and accelerate it by 10x. So imagine being able to, with one server, do the job that it normally takes 10 servers. So as one example, that could be a great help to someone in the operations side trying to deal with increasing requirements for real-time data analytics.
Increasing requirements also, is there a security play here as well? Does it make things a little bit more safe for?
Yeah, absolutely. So FPGAs can also encrypt data quite easily. FPGAs can appear as a plug-in card in some cases, a PCI Express plug-in card. In other cases, they can take data directly from a network and do inline acceleration. So FPGAs play a role in compression, encryption, fast lookups. So these are all strategies to accelerate data analytics. And again, keeping the FPGA hidden underneath a framework so that nobody has to ever rewrite their application code.
So keep it hidden. Is there an architecture or a best practice, or is there some way that a DevOps engineer can get going with this and understand what to do?
So being Intel, of course, we always have some frameworks for people to ease the implementation of things. And for the DevOps person, they'll probably be aware of these frameworks, but for the end user, they won't. But for the DevOps person, Intel has announced yesterday the first ever Intel programmable card. It's a PCI Express low-profile card with an FPGA on it, Intel branded, generally available in the first half of this coming year. As well, Intel has announced a framework to aid with developing applications for this card to make it easier to move to new generations of FPGA cards. And in fact, even the host driver interface is open sourced on GitHub. So what customers like to see in terms of some stability. And then as well, as I mentioned at the higher level, we could put this card underneath, for instance, a Spark implementation, doing compression, again, completely hiding the FPGA.
So this is going to play well for people doing CI and CD, continuous integration, continuous deployment. Is that going to make it easy to almost like change the wheels on a moving vehicle? I mean, is that where we're going here?
Absolutely. So the cloud service providers have been very good adopters of FPGAs because they're an environment that's constantly changing. So Microsoft, for instance, has shared that they like FPGAs because as algorithms change quickly, they can accelerate them with the FPGA, whereas with a traditional ASIC approach, it might take a couple of years to design a chip and a test it and bring it up. So absolutely, for new algorithms that are constantly appearing and for flexibility, you can't match what the FPGA can provide.
So Mike, if you and I sat down 12 months from now here in New York City again next year, what would you like to say is different with Intel, your FPGAs, and your offerings to a DevOps engineer? What would you like to see different?
So I think a year from today, I think one of the big differences is we'll have some really nice customer use cases to share. So this card, as I mentioned, is launching in volume first half of this coming year. A year from now, we'll have some real nice quantified acceleration results and some enthusiastic supporters talking about how it really helped them increase the workloads within their data centers and move things along faster. So I would say a year from now, I hope to be talking to you, sharing some of these exciting end customer case studies.
And so when you say release first half of 2018, worldwide release?
Absolutely.
Okay.
Yeah, absolutely. So I like to say that Intel is usually on the approved vendor list, so it should be pretty easy for a customer to be able to order one of these cards, get a prototype going, and then hopefully go from pilot to production.
Excellent, Mike. We look forward to that conversation in 12 months.
Likewise. Thank you.